Hello and welcome to a new session. So we have dealt with the basics of Python till now, like declaring a variable, functions, loops and all. So from this session onwards, we will be dealing with how to do data analysis using Python. Python has been an exceptionally valuable programming language for not just developing a particular application, but also for enabling data scientists and researchers to find solutions to complex computational and mathematical problems. The versatility offered by the programming language effortlessly allows it to be used in a variety of domains with little trouble. So what makes Python the ideal choice for a data scientist? And the answer is it's easy to use and its debugging nature. But calling Python the best choice for a data scientist would not be fair without mentioning its diverse collection of libraries and packages. Now let's deal with the content part. So we will be dealing with Python libraries, understanding Pandas in Python, and Pandas is one of the major libraries that we will be dealing with. Why do we choose Pandas and different file formats that Python libraries would support, datasets, data frames, and how to create a data frame. It can be from a different data structure or it can be from an existing data storage, like it can be from a CSV file or it can be from an HTML file, etc. So, and we would deal with some examples in Jupyter Notebook, and we would deal with some basic operations with DataFrame too, and we want to move to advanced operations in the coming sessions. Okay, so now let's move to standard libraries in Python. So before moving to all the libraries like Pandas, NumPy and all, we need to know what do you mean by standard libraries. So it's a set of skills that Python has by default, and it's really very extensive and it offers a wide range of facilities for the user. And and standard libraries have some built-in modules. So modules is a large number of predefined functions, and it's available as a part of libraries bundled with Python distributions. So for example, mathematical functions is a module, mathematical functions for complex numbers is another module, and pseudo random number generation. So all these are modules that are available in standard libraries. So in a nutshell, you can say that Python library is a reusable collection of codes that you may want to include in your programs. Now let's deal with different types of Python libraries based on task or function, and they are Pandas, NumPy, Matplotlib, Seaborn, TensorFlow and PyTorch, and we will deal Pandas in detail in this session. Pandas is basically used for data manipulation and analysis, and NumPy is used for data cleaning and manipulation. And after all, we need to present our data in a meaningful way, and Matplotlib is used for that. So in brief, with all these libraries, we can present our data in a meaningful way after doing the analytical part. Okay, now let's deal with Pandas in detail. Pandas stands for Panel Data System, and it's a modern, powerful and open source Python library for data analysis, data manipulation and data visualization. It's a library which can perform all the functions or the functionalities required for processing data, and that in an efficient way. So it is mostly used in data science and machine learning these days. And why Pandas? So we use Pandas because it supports a variety of data sets or data files like CSV, Excel, JSON and HTML. It has functions for selection, filtering and manipulation of data. For example, if you want to compare the sales data of two different regions, we can do that in an efficient way using Pandas. Or if you want to compare the performance of a particular salesman so within two regions, we can do that with the help of Pandas. And along with data manipulation, Pandas have the features for exploring data in a meaningful way. Another major reason for use of Pandas is the support from developer community. Okay. Next, we will deal with how to create data frames. We can either create data frames with the help of list and dictionary, or we can use the existing data sets, and it's up to the user to choose. And we would see more examples when we come to Jupyter Notebook. Now let's see how to create data frames in Jupyter Notebook. So whenever we begin a project, the first thing we need is a dataset. While there are many datasets available online, sometimes we wish to try with our own dataset. So let's try that first. We can create our own data frame from list and dictionary. So let's see one example. For that, we need to first import the libraries, that is pandas. Import pandas as PD. Okay, after that we need to create a list. Let me create one list. Li is equal to apple, orange, mango and kiwi. Okay, after that we need to create our own data frame. For that, df is equal to pd dot data frame li. Data frame is a two-dimensional data structure, that is data aligned in tabular format. It basically gives an overall view of data. So pandas data frame consists of three basic components. They are rows, columns and data. Okay, now if I want to display this data frame, print df. Okay, so df is the name of my data frame. Now I can see the data frame. It's a simple one. All the fruits are listed over here and you can see the row numbers over there. Next, let's create data frames using dictionary and list. So in this case, I'll have two columns, name and marks. So let's try that. Data is equal to name, and that's the name of my first column. Let me create list of names. Steve and Harry, Taylor, and let's say Matthew. So here are the list of names. Now let's move to the marks. Marks. It can be 45, 34, 56 and 32. Okay. Now let me create a data frame, and this time the name of the data frame can be df1. So pd dot data frame data. If you want to display the data frame, I can use the print function df1, and you can see that the data frame got displayed, and the first column is name and second column is marks. You can see the row numbers over there. I hope you guys have got an idea about how to create data frames using list and dictionary. Now let's see how to create a data frame with the existing datasets. So now I'm going to read a CSV file. For that, let me create another data frame, that is df2 pd dot read underscore CSV, and I need to give the file name over here, and the file name is sample.csv. So read underscore CSV is a function name, and inside the function bracket I need to give the file name. Okay. So here it is. This is my data set, and you can see all the columns over here. All the rows are not displayed. The first 5 rows are displayed and the last 5 rows are displayed. You can see that the number of rows have been mentioned over there, and there are 14 columns for this data set. So these are the column names you can see over here. I can show you the 14 columns mentioned over there. If I want to see the number of rows and columns separately, I can do that. df2 dot shape. I can see that there are 1 lakh rows over there and there are 14 columns. And if I want to display the first 5 rows, I can use the function head, df2 dot head. So it displays the first 5 rows. If I am not mentioning any number inside the function bracket, 5 rows will be the default value. So I can see 5 rows and all the columns are displayed. If I want to give a specific number, I can do that. df2.head 10. Now it will display the first 10 rows from 0 to 9. Now if I want to display the final rows, I can do that with the help of df2.tail, and the last 5 rows got displayed. So 5 is the default value if I'm not mentioning any number over there. If I want to display all the column names, I can use the columns attribute. So df2.columns would give me all the column names. Okay, so these are the names of all the columns in dataset. And if I want to display the content of a specific column, I can do that. I want to display the contents inside the column name units sold. Units sold. You can see that the contents are displayed over there. I hope you guys are okay till now. Now let's see ilog function in Pandas. So why do we use this? In simple terms, if you want to select rows or columns by their position, we use ilog function. So we are still with the same data frame, that is df2, and let's see some examples. df2.ilog colon 5. So it displays all the 5 rows, or we can see that all the first 5 rows got displayed, that is from 0 to 4, but all the columns got displayed. All the columns of this dataset got displayed, and I can do this with columns too. For example, if I want to select columns by their position, I can do like this: df2.ilog colon 2. So here it displays all the rows, but only 2 columns got displayed. Okay, you can see that 1 lakh rows got displayed, but only 2 columns are displayed, that is region and country. Now if I want to select only some rows and some columns, I can do that. So let's try one example. df2.ilog, and I want to select rows from 5 to 10. So 5 to 10, and I want to display only 3 columns. Okay, so 3. So let's see the result. You can see that only 5 rows got displayed and 3 columns got displayed. Okay, and now I can use another example or another way to do this. Or suppose I want to select rows from 5 to 10 and columns from 10 to 40. I can do that. df2.ilog 5 to 10. Okay, and columns from 10 to 40. You can see that the columns, it excludes the first value, that is 10th column, but it includes the final column, that is 14th column, and 5 rows got displayed. I hope you guys have got a basic understanding about data frames and data sets, and in the coming sessions we will be moving to some more advanced topics. Have a good day. Thank you.